These are the homework solutions to day 5.4. In this question, we're given a trinomial equation, x squared minus 2x minus 24, and we're being asked to figure out what the y-intercept is, the x-intercept or zeros, and the axis of symmetry. Figuring out the y-intercept is quite easy. All we need to do is look at this value right here, and this becomes our y-intercept. Now, to figure out the x-intercepts, we need to factor this. Now, there's no greatest common factor that we can use to reduce it any further, so we'll go straight to the product sum method. So we're looking for a pair of numbers that multiply to negative 24 and add to negative 2. And those numbers just happen to be 4 and negative 6. So our factored form is x plus 4, x minus 6. If this is our factored form, then our x-intercepts are going to be negative 4 and positive 6. We can add that to our answers. Our axis of symmetry is going to be that imaginary line, imaginary vertical line, that passes halfway between the points negative 4 and 6. And we can calculate this by adding these two together and dividing by 2. That gives us a value of 1. So we can say our axis of symmetry is 1, and that can be expressed as an equation, x equals 1. And I've put a graph here to further illustrate all these answers. Here is our y-intercept. Right at the y-axis, the graph crosses the y-axis at the point negative 24. Here are our x-intercepts, negative 4 and 6, where the graph crosses the x-axis. And here is our axis of symmetry. It's a vertical line where x is always 1. In this equation, y equals x squared plus 6x plus 5. Again, we're asked to find the y-intercept, the x-intercepts, and the axis of symmetry. Our y-intercept is simply 5. Now, to calculate our x-intercepts, we need to factor this. This can't be reduced with a greatest common factor, so we'll go straight to sum product method. And we're looking for a pair of numbers that multiply to 5 and add to 6. And that pair of numbers just happens to be 1 and 5. So if the factored form is x plus 1 and x plus 5, the x-intercepts are going to be negative 1 and negative 5. Now we're asked to find the axis of symmetry. That's simply the halfway point between these 2 points, negative 1 and negative 5. We add them together and divide by 2. It gives us a value of negative 3. That's our axis of symmetry. Here's a graph of x squared plus 6x plus 5. And you can see that the y-intercept is indeed 5. The x-intercept is negative 1 and negative 5. And the axis of symmetry is negative 3. In this question, our equation is y equals x squared minus 8x plus 7. This 7 right here is simply our y-intercept. Now we have to factor this to find our x-intercepts. Again, there is no greatest common factor that we can reduce this by simply, so we go to our product sum method and ask ourselves, what is a number? What are two numbers that will multiply to 7 and add together to be negative 8? Those two numbers happen to be negative 1 and negative 7. So if our factored form is x minus 1 times x minus 7, then our x-intercepts are positive 1 and positive 7. To calculate the axis of symmetry, we simply add 1 plus 7 and divide by 2, and that'll give us a value of 4. So the equation for our axis of symmetry is x equals 4. And looking here at the graph, we can see that our y-intercept is 7. Our x-intercepts are 1 and 7. And our axis of symmetry is x equals 4. Question B here. Again, to figure out what the y-intercept is, we simply look at the c value. So the y-intercept is 42. Now, to figure out what the x-intercept is, we need to factor 2x squared minus 20x plus 42. And it just so happens that we can use our greatest common factor of 2 to reduce our trinomial a little bit. So we do that, we get 2 bracket x squared minus 10x plus 21. Now we can ask ourselves, what are a pair of numbers that will multiply together to be 21 and add together to be negative 10? Those two numbers are negative 3 and negative 7. But when we factor this, we have to remember to bring down our greatest common factor and put this here as well. But inside the brackets, x minus 3 and x minus 7 tells us that our x-intercepts are going to be positive 3 and positive 7. So we'll write this down here as our x-intercepts. To calculate the axis of symmetry, we simply add 3 plus 7 and divide by 2. It gives us a value of 5. We can say that our axis of symmetry is 5, and the equation for that is x equals 5. Here on our graph, we can see that the y-intercept is 42. Our x-intercepts are 3 and 7. And our axis of symmetry is right here along the x equals 5 line. In this question, our trinomial is 3x squared plus 15x minus 42. Once again, we can easily discover that our y-intercept is negative 42. Write that in here. And now we can start factoring to figure out what the x-intercepts are. This equation has a number in front of the x squared. We say that the coefficient of the x squared term is 3. So in this case, we can reduce our equation right here with a greatest common factor of 3. So we'll write that out. Put the greatest common factor here. Becomes x squared plus 5x minus 14. Now we look inside the brackets and see if we can reduce this further or factor this further. We're looking for a pair of numbers that multiply together to be negative 14 and add together to be positive 5. Well, a pair of numbers that do that happen to be negative 2 and positive 7. But when we write out our factored form, we have to remember to bring down our greatest common factor and stick that in the front. So if the brackets show a factored form of x minus 2 and x plus 7, then our x-intercepts are positive 2 and negative 7. Our axis of symmetry is a line halfway between 2 and -7. So we'll add these two together and divide by 2, and that'll give us a value of -2.5. That's our axis of symmetry. So the equation for our axis of symmetry is x equals -2.5. As you can see with our graph, our y-intercept is right here at -42. Our x-intercepts are -7 and 2. And our axis of symmetry is right here along the line x equals -2.5. For this question, our equation is y equals 2x squared minus 6x minus 36. Again, our y-intercept is simply going to be -36. And now we can start factoring. We have a greatest common factor here, which we'll use to reduce our trinomial a bit. So the greatest common factor is 2, becomes 2 bracket x squared minus 3x minus 18. So we're looking now for a pair of numbers that will multiply together to be -18 and add together to be -3. And those two numbers just happen to be -6 and +3. Again, we have to bring down our greatest common factor of 2 in front of the brackets. But if inside the brackets our factor terms are -6 and +3, then our x-intercepts become +6 and -3. Our axis of symmetry is a point halfway between 6 and -3. We'll add 6 plus -3 and divide by 2. Gives us a value of 1.5. So our axis of symmetry can be expressed as x equals 1.5. Here's our graph. You can see that our y-intercept is -36. Our x-intercepts are -3 and 6. And our axis of symmetry is x equals 1.5.